Hi, today I'm going to look at Kinect WebCam, an old project of mine that I haven't touched in years. Kinect WebCam is a direct show filter that turns a Kinect into a webcam, and it supports both the original Xbox 360 Kinect and the newer version 2 Kinect that was introduced with the Xbox One and also available for PC. Now, modern Windows versions seem to include support out of the box for a Kinect WebCam, but in 2014 that wasn't the case yet, and that's when I wrote this. The goal for today is going to be to build the project on a modern machine, fix any issues that come up, improve the build instructions, and test it on Windows 10. Secondary goal will be to add continuous integration, but that will probably have to wait for another video. Okay, so the build instructions state that there's a CMake file. So we got CMake installed on this machine, no problem. And it also requires the Microsoft Direct Show base classes. Those are utility classes to help build Direct Show filters that were included as an SDK sample in the Microsoft Windows Development Kit. Now, I wasn't sure about the licensing issues, so I did not copy those files into this repository. If you want to build the Direct Show filter, you have to fetch them yourself, include them in a directory before you can build it. But luckily, Microsoft has released the classic samples on GitHub a few years ago, so we can just clone the repository, take what we want, what we need, and off we go. It also states it requires OpenCV. It's used for some image manipulation and color space conversions. The Kinect SDKs to communicate with the Kinect devices. And what's missing in this list is Qt 5, because there's a setup program that controls some settings of the filter, and that uses Qt as a UI toolkit. Okay, let's start by cloning the repository. Git clone. That's one. Now, next step would be to fetch those SDK samples, but I don't want to clone the entire repository. So we're going to do a sparse checkout that just fetches a single directory. I've got the command open on my other screen so I don't mess it up while recording this video, because a sparse checkout is not something I do regularly. Sparse and the URL of the Microsoft repository. I forgot to copy it. You see that checkout went rather fast and it only did 2 files. But we're going to need the sample directory, so we're going to change the options of the sparse checkout to that subdirectory. If I can just copy it, yes. Here we go. 96 files. Going to switch to the other screen and open the README. It says Microsoft Direct Show base classes stream base. So if I remember correctly, that's the directory it expects those samples to be at. So let's switch to Kinect WebCam and copy the Windows Classic samples, 7 samples, multimedia, direct show, base classes to stream base. Okay. Next step would be to try and build it and see what issues we run into. We're going to run into issues, of course, because we haven't fetched the dependencies yet. But we'll fix that when it comes up. So CMake, put it in a sub out of 3 build directory. Use generator for Visual Studio 2019. Build it for 64-bit. Okay, should be it. And we've got a few warnings about compatibility with an older CMake version that will be dropped from a future release. Okay. And Qt is missing and OpenCV is missing as expected. Okay, first we're going to get rid of those warnings about the version incompatibility of deprecation warning so it doesn't clog up the view. I'm just going to bump the version we require here to be the minimum that is going to be supported in the future. So we got some CMake files in a subdirectory as well to build the Streambase library and the UI settings program and the filter itself. So they're all at 2.8.12 now. So we have less warnings now. Just OpenCV and Qt. Okay, for the dependencies, we're not going to install them by hand. It's going to be too complicated, and I want to make it easy to replicate in the continuous integration server. So we're going to use a C++ package manager, and I've chosen Conan for this. I've already experimented a little bit with package managers, and Conan uses binary packages, which is going to be nice for Qt because I really don't want to build it now on this machine. So I've got an example open on the screen to guide me, and we're going to create a configuration file for Conan. So Conan file.txt in the root of our project with the requirements. So I'm going to have to get OpenCV, look up the package. Probably can do it on the command line, but I'll just use a browser. But we're going to need an older version that was current about 6 or 8 years ago. So let's choose 2.4. It's either 2 or version 3 I used. I think version 3 was in beta or pre-release when I worked on this, so we're going to choose version 2. Okay. We're first going to try OpenCV by itself. As a generator, I'm going to use CMake find package because the CMake already uses find package commands to configure Qt and OpenCV, and I don't really want to change. I want to minimize changes I have to make. So let's use that. And tell Conan to install dependencies, but use a debug build type. Okay, it's going to fetch OpenCV and its dependencies now. While it's doing that, I'm going to change the root CMake file to include some Conan setup so that it knows where to find these find package files it created. put that here. So now when we run the CMake configuration again, we get a whole lot of Conan output about OpenCV and only the Qt errors. Okay, so then we'll add Qt to the Conan file. Not version 6, but version 5, 15.3. And we're going to add an option so that we build the shared, we let Conan download the shared libraries of Qt. So I don't want to statically link the files because it's rather complicated with Qt and it's probably going to violate the license. So we don't want to do that. Excuse me. Okay, so let Conan run again. We're too far in the history. Go to your site, yes. So now it's going to download the dependencies of Qt and Qt itself, I hope. Just let an awkward silence, and we're there, yes. Find Qt, so it did something with Qt, that's good. So we can try and build. No, we have to run configure CMake again. So let's do that. And it's still giving errors. Find Qt5 widgets and find Qt5 GUI. Right, we only had one find package for Qt here somewhere there. So it's probably using the newer component style targets. So we have to change the CMake file anyway, that's not a problem. So find package, components, widgets and GUI. And configure again. Okay, we got another error. Qt use modules is not part of the official API and might be removed in Qt6. Okay, Qt5 modules. Okay, that's specifying the linker flags, I guess. So, libraries, target linker libraries, config. We're just going to do it manually. So, Qt5 widgets and Qt5 GUI. Okay, try again. And the build files have been written. So let's build the project and choose the debug configuration. Maybe let it run in parallel so we don't have to wait as long. And the awkward silence while waiting for the build to end isn't as long. Okay, we got some nice colored warnings and an error. QPA Q platform native interface. Sure. And some more errors. Kinect wrapper. Right, it was because I don't have the SDK installed yet for the Kinects. We'll fix that. So let's fix these errors first. The Kinect errors. So open the CMake file for the filter. We're going to add options so we can choose which SDKs we're going to build against. So add an option, enable Kinect v1 enable building, enable the Kinect V1 SDK, and we'll turn it off by default, and do the same for V2. Now we want to exclude the Kinect V2 files or the Kinect V1 files when the respective option is disabled. So this uses file globing to automatically build a list of source files. Don't want to do that, we want to control it by hand. In the past I used to use file globing a lot, but in the more recent past I've just started adding the file lists to the make files themselves. It's just simpler because you always have to force CMake to run again if you add a file, so might as well just change the file, and it's nicely documented in source control history that way. So okay, well, here is a target. So target sources for Kinect WebCam, private. Let's fetch those files. Source, we had common, these files. Okay, that did not copy it, but now we have. Okay, and they have to be in the common directory, and the files for the filter, well, the source files anyway. Okay, those are all of them. Now let's move some of those behind the configuration flags. V1 and if so, target sources to add will be device Kinect and Kinect wrapper. And we also want to add a compile definition, so we can check in the source if the option has been included or not. So for Kinect WebCam, a private option that says have Kinect V1. Okay, normally we would use a config file or something that we can include, but there's only two options, so you're just going to go ahead and do it on the command line. Same for version 2. Version 2, get the device files and the wrapper files. Okay. And now try to build it again. We're probably going to get some other errors, because now those device classes won't be there, but it's still going to try to instantiate them. And just wait while it rebuilds the base classes. And it still fails. Oh, I copied the Kinect wrapper lines instead of moving them. That's not going to work. Let's just do, I'm always going in the wrong direction. Let's do a quick check. Yes, okay. This should be better. Yeah, we got a whole bunch of errors. So these warnings are about missing debug information for OpenCV and stuff. That's okay. We're not going to debug into OpenCV. And yes, errors for the missing device classes. Okay, so we just have to make sure they're not instantiated anymore. That's going to probably happen in the device factory. So device factory, yes, make unique device connect. Okay, let's just only do that when have Kinect v2 is defined and when v1 is defined. v1 here, I'm just going to copy it. It's going to be faster. And v2 this is not going to compile, so let's just do this, that, remove the else, and we'll have this as a fallback. So this means we can test the filter without even having a Kinect. Just going to show an error message in the video stream. Okay, so now the build should be better, but we still got an error message here. And the QPA platform interface is still a Qt error. And those linker warnings are annoying, but well, they're not a problem right now. But this error is rec server 32. Oh, it's trying to register the filter from the build file, which, okay, it's an odd thing to do. And it only works if it's running in an elevated command prompt. So let's just remove that bit. And wait for the build to continue. Right, Qt error. Q platform native interface, no such directory. Okay. It's in the files in the file Qt utils .cpp. Native interface. Native parents, probably the code to get the window handle. I'm guessing that's a private interface because it's not platform independent. Let's look at the UI CMake file. Got Qt5 GUI private includers here. Maybe that's named differently in the find Qt5 file generated by Conan. So let's just look at that. Find Qt5, and in your case when we're searching, let's look for private. Some CMake files, core private, GUI private. Let's look at that. It changes some include directories, but it's got a target GUI private. Let's just use that instead of this include directory. So targets, link libraries, Qt5, GUI private. And build again. Yes, it seems to continue now. Let's just wait. And it's done. Okay. Let's test the filter to see if it works on our Windows 10. If it doesn't, well, yeah, then we don't have to really continue much because there's no point. But I'm guessing it's going to work. So let's just register it from our elevated command prompt. Run as administrator. Yes. Go to Kinect WebCam. The build directory, output, runtime. I think I saw runtime somewhere. It's going to be here somewhere. Debug. And register SVR32. Silent Kinect WebCam. Yeah, silent now. Well, it succeeded. Okay. Let's see if we can make a direct show graph and see what output we get. So Kinect WebCam is our filter. Add the video renderer, play, and it's on the other screen, but yes, we get the no Kinect error message. Okay, next step. Let's try to get the configuration program kwconfig running. We can use that to try out the filter because it has some easy options to change the resolution and some other stuff, but it's probably not going to start because it's missing the Qt5 DLLs. Now I know I have some installation stuff in here, but I don't know how much it's going to work if it tries to fetch the Qt5 DLLs. We can just try it, but I don't know if it's going to find it. So let's do target install, and we got a whole lot of error messages. Command set local and local. I don't know what those are all about, but well, it can't find the platform Windows DLL, so it's going to be different. But I anticipated that, so I did some research, and I think it's going to be easier to let Conan copy the dependencies from the directory it installed it in to our target directory. So we're going to remove or disable all this stuff that has to do with Qt5. Run the install again, and okay, it works. I'm going to unregister the filter from the build directory, so we can register the filter in the install directory. But we're going to let Conan copy the DLL files we need from its binary directory to our install directory. So we're going to need Qt5 DLL The reason for the wildcard is that the DLLs are named differently in debug mode and in release mode. So there's a D in debug mode. So we're just going to say star, put it in the install directory. Same for Qt5 widgets and GUI. Maybe do it alphabetically. And then we're going to need the platform, and it's in a different directory, our data dir, plugins, platforms, Q Windows DLL, also put in a wildcard, and we'll put that in the install platforms directory. We run it, and while it's running I'm going to, oh, I didn't even have time. I don't have to run the CMake, I have to rerun Conan. So Conan install as build type is debug, unrecognized field import. Right, it has to be imports with an S. So let's run it, and it copied 4 files. Okay, then we should be able to start it. Let's find the directory first. Start the kwconfig. Okay, it's complaining about not being able to utilize Kinect WebCam, and that's right because we unregistered the filter from here. And we're going to register it from the install directory, not unregister it, register it. Succeeded. Okay, so now when we run kwconfig, it says no Kinect available. Nice. Yeah, it's normal that it says it no Kinect available because we haven't linked against the Kinect SDK yet. But okay, this works, that's nice. We see the output of the filter and the Qt dependencies are all in place. So next step is going to be to install the Kinect SDK. It's still available from Microsoft at this page with cookies, of course, but I've already downloaded it, so let's just install it. Agree to disagree with the license terms and just let the installation process run. Okay, it's almost done. It's done. So now let's rerun CMake, the configuration of CMake, and add that enable Kinect v2 flag. Turn it on, and build files have been written. Okay. Build it in parallel tree. You're going to rebuild some files, Streambase as well. Okay, that's almost finished. It compiles device Kinect v2 and Kinect v2 wrapper, and all those nice warnings. So we have to install it. And now if we run the config program, we should get output from the Kinect. And yes, it's pointing just over my shoulder. And we have the wall and the part of my closet with my music collection there. So that's good. Now, green screen should turn on the green screen mode when it will try to detect a human and turn the rest of the screen black. So that's not really working. Okay, something to check out. Let's see how that works. So the config program and the filter communicate settings through the registry. So the filter is monitoring the registry and the settings program changes settings and then the filter picks it up immediately. So probably something's going wrong in the registry. Let's see how it works. Let's look at the code for the settings. Settings. So we got a list of settings: tracking enabled, tracking joined, green screen, and which Kinects to use. So the settings: CPP, read write, load, save. Okay. HC key open X. Fails. Let's just run this under a debugger. That's going to be easier. Open Visual Studio. And of course, it chooses the other screen. Going to want to run kwconfig as a startup project. And we're going to change the properties of all configurations for debugging to the working directory, to the install directory. So it can find those Qt dependencies. Okay. Source file, no sources. Settings. Okay. Oh, it's going to be here in common settings. And see if we can zoom in a bit. Make this smaller. Jump down to rack open keys and let it run. No Qt platform exists. Wait. Starting it from the right directory, right? Install. Yeah. And install as the platform's Q Windows DLL. Running it from here works. Okay. There's no platform DLL could be initialized. Huh. Alright, I'm not going to waste time trying to figure that out now. Just copy this to the directory where the executable actually is. Try again. And now it works. Okay. Change the green screen setting. Breakpoint is hit. And it fails. So why does it fail? Well, because it returned an error. No debug output. Well, that's nice error handling at least. Well, probably because nobody created that register key. Let's just see if it exists. This HKey current user software not system key. No, it doesn't exist. So we're probably going to have to create it first. Search for open key. Yes, I agree. Open key X. A handle to recreate key X. Create key X sounds better. Alright. So we're just going to change this to rec create key X. This current user is, no, that's too small. Damn it. Current user, it's reserved. Okay, class maybe ignored, can be null. Right, null. Then options, right. Options, option create link. Options is 0. Then we got Sam desired, this is the access rights. It's right. That's good. Security attributes is probably going to be null. Pointer to the HKey result is still the same. And output disposition is probably can be null. Okay, null. So let's run it. Let's build it and run it again. Okay, we've got image. Can make it bigger. Enable green screen. And okay, now it works. But don't know if it's picking it up. Let's just run in front of the Kinect to see if it... Well, tracking is working. But green screen isn't. And the flickering is because probably the light is too dark for the Kinect. Okay, just let's look in the registry again. Kinect WebCam is here, yes. And we got green screen enabled. Is 1. Turn it off. Green screen enabled is 0, so that's working. But the filter isn't picking it up or isn't doing it. Alright, now it's staying black. It probably didn't pick it up automatically. So maybe it only checks for settings when it's initialized. I'm not sure, I can't remember that. But now, if I walk in front of the Kinect, it should see me, track me, and only show me and a nice halo. Cool. So we can also change the joint on which it tracks. So now it was doing head tracking, we can say we do it by right hand. Just change the resolution to be sure. And now, when it sees me, it should be tracking my right hand. Cool. You can see the problem with the resolution of the depth sensor is the resolution of the depth sensor is lower than the resolution of the image sensor, so you have this fringing around the ends. But okay, I think we've accomplished all the goals I set out for the day. So the software is building, it's working under Windows 10. So we just have to clean up the build instructions a bit. I'll do that off screen. And next time I'm going to look at the continuous integration part that I mentioned in the beginning. So I'll be back. Hopefully you will be too. Good night, and until next time.